Alright, quick little show of my temperature controller setup. So this is a Inkbird ITC-1000F. You can see it right here on the top. And this is just a little breadboard I have to make the circuit easy. And then the other part of this is a small fan that I'm going to use to circulate the air a little more. And then an LED light. So I've just got it hooked up to a lab power supply, and when I turn it on, so the Inkbird has, kind of hard to see, but essentially I'm feeding it 12 volt power over here on these leads, and then what you use is the cooling circuit as a switch. So you got to feed 12 volts into one side, and then it's basically acting like a relay, and it closes the switch and then provides power. So this would be led back to the Danfoss controller on the two pins that the thermostat hooks up to. So let me turn this on. I'll kind of show you how it works. So right now I'm running 12.6 volts, which I think is kind of standard, and this little fan is running nicely. And so the way it works is there's a little temperature bulb, and this would go in the refrigerator box. And if I put it in this reasonably cool water, I've got this set to 60 degrees just because it's easier in trying to do refrigeration. So once it gets to 60, you can see the little LED light. It'll kick off, and the fan shuts off. And then if I take it out of the water and heat it back up again, and the differential I think I set was 6 degrees, so it should turn on at 60. So there you go. So it turned on, LED light came on, and the little fan's running. Now the only thing that's other than wiring is you got to run a resistor, which is this little guy here, for the LED light. And I think I used a 1.5K resistor just to get this LED light down to where it was not incredibly bright. I don't like bright lights just shining. So if you run this, well, you need a resistor anyways, because these little LED lights will burn out because there's no resistance in them. So you got to add a little resistor in line. So that's what that little guy is. I'll draw out a circuit diagram, and I'm not an expert here. I just fiddle around. So anyways, that kind of works pretty nicely. It's pretty cheap for all this stuff. This thing was like $13. These little fans, which I got kind of a pair of, or I don't know, a few dollars. They're DC brushless fans. I thought that was kind of interesting. Little computer fans. Come on. So 0.15 amps. And actually that's a good point. So this little guy does heat and cooling. Now obviously we're not heating the refrigeration box, but right now it's fallen below the set point of 60 degrees minus the differential of 6, so 53 degrees. It's now trying to heat, and I don't think that'll be an issue, but there is an electrical draw, which if we look at the old Fluke, 53 milliamps. This isn't very accurate. So right now it's saying, well, it's too cold, so I'm trying to heat it up. Well, obviously I don't want that, and I'm wondering if there's a way to turn it off. I can't seem to find it, but hopefully it shouldn't fall below the set point to where it's trying to heat up the refrigerator, but it's more just the case that it's trying to close the heating relay circuit and eating up some amps that is just totally unnecessary. But that shows you what it looks like when that's kind of the amp draw. And then if we take this out and heat it up in my hand to get back up to the 60 degree cooling, so right now it just kicked off. So 17, 18 milliamps, and there it's trying to cool down again. So 150, 145 milliamps for this entire circuit, including the fan. I did put a rheostat 10K potentiometer on the fan to try to slow the fan down to save amps. I'm not really sure it's worth it. It does work. You can slow the fan down, but even if you try to slow it down too much, it just tries to lock up, and it's still an amp draw, so it puts out a fair amount of breeze, and I think it's worth the draw. So it's calling this as 0.15 amps, but I don't think it's actually pulling that based off of the amp draw of the entire circuit. This little guy pulls out 0.18 milliamps. The LED light is almost inconsequential, it's so low. But that's because I got that resistor in there. If I pulled that resistor out and put in a 330 ohm resistor, the LED light would be much brighter, but I don't want that. So then I'll show you my circuit for controlling the compressor speed that I built. Okay, so for these Danfoss compressors, you can put a different resistor in place and control the speed of the compressor. And this is all kind of already well-known information. I'm trying to find it in my little diagram, but well, you don't need to sit here and watch me look through the paperwork, but basically you can go up to about 1600 ohms and you will increase the compressor speed all the way up to 3500 RPM. So this is just showing you how I do it, and again, I'm not a professional, but I just have a 10K potentiometer here, and I've got it hooked up to my fluke. Oh, the glare is so bad. To see the resistance, which is essentially 0, although it's calling 4 ohms, but that's just probably the resistance of these cheap little leads. So then if I turn this up, we should go all the way up to 10,000 ohms, which is what these kind of are standardized on. So 2.45.